All right, so I wanted to make sure that we could get to the last type of um, similarity or statement for proving that triangles are similar, which is side angle side similarity. And so this is showing that two sides are proportional with an angle between those two sides that is congruent. And so here they gave us two sides that are labeled, and then we have the angle. You can see the angle between them is right here. So we've got vertical angles, so we know that those two are congruent to each other. That's pretty easy. And then I'm going to go ahead and compare the sides. So I'm going to do the same thing that I did with the side, side, side similarity. I'm going to write these kind of in order. So I've got 6 as the smaller side, and then 12 is the bigger one. I know that 6 should correspond to the 24. I know that 12 should correspond to the 48. These ones are a little bit easier. You might not even need to use your calculator with reducing these, but you still can. So I'm going to go ahead and do that. So 6 over 12, sorry, 6 over 24, and then 12 over 48. Both of those reduce to 0.25, which is 1/4. So this, if we were doing little to big, this would be a 1:4 scale factor. And so we're going to say that this does work for side angle side similarity. And I'm going to go ahead and label the remaining angles that are similar to each other, just so I know how to write that similarity statement. So the small side had the R and the E with it, so I'm going to go ahead and just label these. This was the small side, had the F, and then I'll go ahead and label these. So this is strictly, I'm labeling those angles strictly to write my similarity statement, not because they were given in the problem, okay? So I've got triangle SER is similar to triangle oops, I didn't write the triangle, triangle GER. And that was by side angle side. And I'm going to go ahead and label that. This was side angle side, SAS. All right. For the next one, again, we have vertical angles that are similar or congruent to each other. Now here, if you look at the sides that are labeled, we have a side and an angle, and that angle is not the one that's in between. This would be the angle that's in between the two sides that are given. So this is angle side side, angle side side is not a similarity statement, so we are going to say not similar because it was not two sides and the angles in between them. All right, so I did technically say that you guys only had to take notes on 13 and 14. So if you feel comfortable, you feel like you understand exactly what you're doing for side angle side based off of these two examples, then you are done. When I check the notes, if you have notes for 1 through 8 and 13 and 14, you will get full credit. If you feel like that was not enough for you to understand what's going on and you would like to continue to look at some more example problems, then go ahead and keep watching, and then you'll get some more example problems done to make sure you have complete understanding. So with example 15, they have labeled here that we have two parallel lines. So I'm going to go ahead and draw these parallel lines out. So there's our two parallel lines, and I can see that this right here is a transversal. So we've got two parallel lines and a transversal, and I can see that this right here is a corresponding angle. These are corresponding angles. All right, so we do have an angle, and then we've got two sides and the angle in between them. So it looks like as long as those sides are proportional to each other, it looks like we're pretty well set up for this side angle side similarity. So 22 and 36 are together, and 33 and 54. Actually, I'm going to write these. I kind of did these backwards. I did this over this, even though that's not really how it's written. So I'm going to go ahead and flip those around. I'm going to do, instead, I will do 36 over 22, and I'll do 54 over 33. Okay. So I'm just going to check these. 36 over 22, 54 over 33. I can see those decimals are exactly the same. Let's go ahead and see what our scale factor is. So I'm going to hit that math button, turn it into a fraction, 18 over 11. So that scale factor is 18 to 11. That's what our scales are, bigger to smaller. So now I can go ahead and I can kind of label what's the same now if I want, now that I know that these triangles are similar to each other. So I've got triangle MPC is similar to triangle PQR. So MPC, PQR. Those are the similar triangles. Okay, let's go ahead and do 16. So they already have the angles labeled that are congruent, and I can see it's the two sides that are on either side of those angles. So it's side angle side, side angle side. So it's pretty well set up to be a side angle side similarity statement. I just have to make sure, or similarity congruence. Goodness gracious, it is already set up to be side angle side similarity. I just have to make sure that these sides are in fact proportional. So I'm going to say 45 is the smaller one, 50 is the bigger one. So 45 is going to be compared with 31.5. 50 is going to be compared with 35. And I'm just going to make sure that these match. So 45 over 31.5 and 50 over 35. And those decimals do match up completely. I'm going to see what that scale factor is. 10 to 7. It's a 10 to 7 scale factor. And so the 45 is the smaller side. 31 is the smaller side. And then there's the bigger one. Okay, so now I can go ahead and write my similarity statement. So I've got GEF. Bothering anyone else that I did not go in alphabetical order. GEF, and then HJK. Well, that one went HJK. So I think that's pretty good for the side angle side examples. If you feel comfortable with that, go ahead and shut the video off. If you would like to see some more examples of the side triangles, I am going to do example 11, which I think is a good one because they don't give us all three sides, but you can actually solve for the third side because it's a right triangle. We are going to do that one. And I want to do number 9 as well. So go ahead and do number 9. We have 5, 12, 16, and then 4, 7, 10. So I'm doing the small side, the medium side, the big side. The small side, the medium side, the big side. And now I'm just going to compare these. 5 over 4. 12 over 7, oop, 16 over 10, those are not. So I'm going to say not similar. Those are not similar. Let's try this one. So here we have two right triangles, which means we do have a missing side on both of them, but we can actually find it. So I'm going to call this missing side A. I'm going to call this missing side C. So the Pythagorean theorem says a squared plus b squared equals c squared. Actually, I'm going to do my work off to the side so I don't mess up this area. So I'm going to do a squared plus b squared equals c squared. I have a squared plus 25 equals 169. 169 minus 25 is 124. And then the square root of 144 is 12. So this side is 12, okay? Then over here, I have a squared plus b squared is c squared. This is not looking good for our triangles to be similar, I don't think. Or for our c value to be good. 547.56 equals c squared. So I'm going to square root 547.56. Oh, 23.4. We'll see. 23.4 equals c. Okay. All right. So we've got the shortest, the medium, the longest, and we're going to compare with the shortest, the medium, the longest. We're just going to see how these match up. Oh, okay. All right, so it looks like 5 to 9. I'm going to go ahead and take this last one, turn it into a fraction. 5 to 9 is the scale factor. Little triangle to big triangle is a scale factor of 5 to 9. So let's go ahead and label. So the way that I like to do these ones, whenever we have all three sides given, so I have no, well, this one we had a right triangle that was labeled, but sometimes when you have all the sides but you have no angles, it can be confusing figuring out what letter corresponds to what letter. So I like to find the smallest side and label that, and then find the medium side and go across from that and put 2 there. And then the right angle is always going to go across from the biggest side. So my smallest side, there's 1. My medium side, there's 2. And then my biggest side is always across from the right angle. Okay, so I've got X, Z, Y. So cringy. I did not go alphabetical. V, R, W. There's my similarity statement. All right, so those of you who hung around to get a few more examples, I hope that was enough for you to understand what was going on. Please send me a message on Remind if you need more help as you work on the practice sheet.